Hello everyone, I welcome you to this Max lecture series. This is a video by See Through Max. In this video, we are going to solve system of linear equations by using Cramers Rule. Already we have solved system of linear equations by matrix inversion method. By finding matrix inverse, we have calculated the values for the variables from the system of linear equations. Cramer's rule. There are 5 steps to obtain this one. Few steps which we used to follow for all the problems of same type. Write the system of linear equations in standard form. Step 2. Write A, X and B, where Ax the coefficient matrix, X is the vector contains the variables and B is the vector contains the constant terms. Find delta is equal to determinant of A. This value is not equal to 0. That means if the matrix is non-singular, then only solution exists. Replace ith column vector of A by the column vector B and name it as AI. Now find delta I, which is equal to determinant of the new matrix AI. That means if there are 4 variables in the given system of linear equations, then definitely matrix A is of dimension 4 cross 4 and therefore there will be 4 column vectors, and this step 4 we have to repeat for 4 times. Step 5. Now find the values by using the formula xi is equal to delta I divided by delta for all I. So what this one means, already I have said to you, if there are 4 column vectors means we will get 4 values. That means 4 variables are there. Here I have named the variables as x1, x2, x3 and x4. So every time we will get one value of the variable. Now we will solve a problem. Solve the following system of linear equations by Cramer's rule. The 2 equations are given with 2 unknowns x and y. So those steps we will solve in the same order. So here the steps are also written. Write the system of linear equations in standard form. Here the 2 equations are already in standard form. What it means? First x term, then y term, then equal to, then constant term. The second equation also is like that one. First x term, then y term, then equal to, then constant term. If it is not in this order, we have to rearrange to bring in this order. This is called standard form of linear equations. Now write A, X and B from the system of linear equations in step 1. So here the first row corresponds to the first equation and the second row corresponds to the second equation. And the first column of A corresponds to the first variable. The first variable is x. And the second column corresponds to the second variable y. That is the reason here also x is equal to the first variable here is x and the second variable is y. If I write the 2 equations in such a way that if I write y first and x next means here also I have to change it as yx. Okay. So this is the order which we want to follow, and B is nothing but the constant elements column vector. That means 5, 7. So here I have shown the arrow. So from the first equation we are getting the first row, and from the second equation we are getting the second row for the coefficient matrix A. Step 3. Find determinant of A. So that we have named it as delta. If this is not equal to 0, then only solution exists. Yes, already I have calculated. So determinant of A is not equal to 0 here because the value is minus 8. So solution exists. Now what we want to do, replace ith column vector of A. That means how many column vectors are there for A? There are 2 column vectors because there are 2 unknowns, 2 variables x and y. So first replace ith column vector. That means first we will replace the first column vector and this will be replaced by B, the constant elements column vector. So that means 1, 3 will be removed and that will be filled by 5, 7. We'll get a new matrix and then for this one find delta x. Now find the determinant of this one. We will get minus 24. This value can be negative or positive or even 0 also. No problem at all. But only thing, delta should not be equal to 0. Do the same for all the variables. That means here we have one more column vector, that is for y. So we will repeat the process one more time for column 2. So here replace this 2 minus 2 by 5, 7. And again calculate delta y, that means determinant of ay, the new matrix. Here the value is minus 8. Step 5. Now find the values by using the formula xi is equal to delta I divided by delta for all I. Here there are two variables. So we have already named as x and y. So this is nothing but x is equal to delta x divided by delta and y is equal to delta y divided by delta. So x is equal to delta x by delta and we have got the answer 3. That means the value for x is 3. The same way substitute values for delta y and delta, we will get the value for y is equal to 1. Therefore, the solution is x comma y is equal to 3 comma 1. Check the answer is right or wrong by substituting these two values in the given equations. Now one more problem we will solve, but this is of 3 cross 3 matrix. Solve the following system of linear equations by Cramers rule. The three equations are given. So immediately when you look at the equations, you want to check about whether they are in standard form or not. Here this is for x, y and z, then followed by equal to, then constant terms. Then this is already in standard form. So directly I will write the matrix form. A is equal to is a 3 cross 3 matrix and x is equal to x, y, z because there the equations are in the same order x, y, z and the constant elements column vector 11, 9 and 25. Find determinant of A. Here it is minus 22 and this is not equal to 0. So definitely solution exists. Now what we want to do? In matrix A, remove the first column and replace it by column B to find the first unknown means x. That means AX is equal to, so here already I have replaced the column vector B in the first column. So I have found the steps also, but since we have done many times to find determinant, here I am not going to explain. Directly the value I wish to tell. So delta x is equal to minus 44. Immediately we can find the value for x here. X is equal to determinant of ax divided by determinant of a, which is equal to 2. And this is the advantage of Cramer's rule. See here, without finding the other variables y and z, we can able to find the value for one variable. The same way, if I am interested in finding only the value for z means directly by finding only two determinants, we can able to find the value for z. But if you use other methods, in that case you have to work a lot. Here with the help of only two determinants, this is possible. Now find y. How to find y? Replace the second column vector by the column vector b and find the determinant value. The determinant value is minus 66. Now y is equal to determinant of ay divided by determinant of a. The answer is 3. The same way for z, the value for z is 4. Therefore, the solution is x, y, z, which is equal to 2, 3 and 4. Check the answer by using calculator or by substituting these values in the given system of linear equations. Some points to think. When there are few other methods to solve system of linear equations, in which way Cramer's rule is better than others? Another point to think, if determinant of A is equal to 0, then what will happen to the solution? Because we are not finding inverse at any place, then what is the need for the condition determinant of A is not equal to 0? It means if determinant of A is equal to 0, what will happen? Think and write the answer in the comment box. This is a video by See-Through Maths. Subscribe and click the bell icon to get more updates. Thanks for watching. See you in the next video. Bye.